Welcome to our exploration of cost behavior. After studying this chapter, you should be able to 1. Understand the importance of cost behavior in managerial decision-making. 2. Describe linear cost functions and the 3 criteria to classify costs. 3. Use the high-low method to estimate a cost function. 4. Use regression analysis to estimate a cost function. 5. Evaluate and choose cost drivers using statistical criteria. 6. Recognize nonlinear cost behaviors including learning curves. Now let's focus on our learning objectives. This slide outlines 6 essential goals designed to guide your understanding of cost behavior. You will explore cost functions, learn how to distinguish variable, fixed, and mixed costs, and master estimation methods such as the high-low and regression analysis. Look at how each objective methodically builds your analytical skills and prepares you for real-world challenges. Which of these objectives challenges you the most? Think and reflect. Next, consider why cost behavior matters. This slide poses the core question. If activity increases by 10%, how will total costs adjust? Through color-coded sections, it highlights key management applications, from budgeting and break-even analysis to pricing decisions, and provides a real restaurant planning example. Reflect on how understanding these cost dynamics informs strategic decisions in business and supports effective managerial accounting. How does this insight change your view of cost management? Consider its impact. Now let's delve into the cost function, a fundamental concept that models how costs adjust with changes in activity. Displayed prominently is the formula Y equals A plus BX, breaking down total cost into fixed and variable elements. The slide also clarifies key assumptions, such as the influence of one cost driver and the significance of the relevant range, ensuring that cost behaviors remain predictable. This model empowers you to approach cost estimation with precision. Finally, we examine different types of cost functions. The slide visually splits into 3 blocks delineating variable, fixed, and mixed costs. Learn that variable costs vary directly with activity, fixed costs remain constant, and mixed costs combine both elements. Each section offers a formula and real-world examples, clarifying how these cost types influence business decisions. Reflect on how each form can impact your financial analyses and operational strategies. Empower your effective strategic planning. Fixed costs. These costs remain constant in total regardless of changes in activity levels within a relevant range. While the total remains the same, the cost per unit decreases as activity increases. Examples include rent, straight-line depreciation, property taxes, and administrative salaries. Variable costs. These costs fluctuate in direct proportion to changes in activity levels. If production increases by 10%, total variable costs increase by 10%. Variable costs per unit remain constant. Examples include direct materials, direct labor, and sales commissions. Mixed costs, semi-variable costs. These contain both a fixed component, base cost, and a variable component, usage-based cost. They change in total, but not in direct proportion to activity changes. Examples include utilities, base fee plus consumption charge, and maintenance costs. Step costs, step fixed costs. These remain constant over a specific range of activity, but jump to a higher level once that activity threshold is exceeded. They resemble a staircase pattern. An example is hiring an additional supervisor once the number of staff exceeds a certain number. Cost behavior describes how specific expenses react to changes in a business's level of activity, such as production volume or sales. In statistics, these behaviors are often modeled using a linear cost function. Y equals A plus BX. Y, total cost. A, total fixed cost. Y-intercept. B, variable cost per unit. Slope. X, level of activity. Cost driver. When classifying costs as fixed or variable, you must consider 3 important factors. Choice of cost object. The same cost can be classified differently depending on the cost object. For example, a supervisor's salary is fixed for the department, but becomes variable when analyzing cost per unit produced across multiple departments. Time horizon costs that are fixed in the short term may become variable in the long term. For example, a 5-year equipment lease is fixed during the lease period, but the company can choose not to renew, making it variable over a longer horizon. Relevant range: the classification only holds within a specific range of activity. Beyond that range, fixed costs may increase, for example, needing a second factory, or unit variable costs may change, for example, volume discounts on materials. Consider the methods for cost estimation as tools in your strategy kit. This slide outlines 4 approaches: industrial engineering, conference method, account analysis, and quantitative analysis, each with distinct strengths. Notice how the highlighted cause and effect note reinforces the importance of linking physical relationships and operational insights. As you review these methods, ask yourself which tool would best solve real cost challenges in your future managerial decisions to enhance effective cost management. Indeed now. Now let's walk through the 6 steps of quantitative analysis as our cost detective adventure. 1. Choose the dependent variable Y, the cost to be predicted. 2. Identify the independent variable X, the cost driver. 3. Collect data on the dependent and independent variables. 4. Plot the data to identify outliers and verify linear relationship. 5. Estimate the cost function using high-low or regression. 6. Evaluate the cost driver using statistical and economic criteria. Imagine embarking on a data detective mission. In this step, you use Excel to create a scatter plot by selecting your hours and cost columns, then add a trend line showing the equation and R-squared value. As you review the chart, look for clusters and outlying points. What to look for? Is the relationship approximately linear? Do points cluster around the trend line? Are there points far from the line, potential outliers? Common causes of outliers: data entry or recording errors, unusual operating conditions, holidays, repairs, one-time events, equipment failure, extreme weather, changes in operations or technology. Step into the world of the high-low method, where cost behavior is simplified using only 2 data points. Begin by calculating the variable cost rate with the formula B equal to the change in cost divided by change in activity. Next, determine the fixed cost by subtracting the variable portion from the total cost. This method, although straightforward and quick, has limitations that require careful consideration when interpreting cost relationships. A closer look. In this practical example from Gator Beach Marts, the high-low method comes to life. Observe the table highlighting March as the high point and June as the low point. Calculate the variable cost by dividing the cost difference by the difference in hours, then derive the fixed cost from the high point data. Finally, use the resulting cost function to predict future expenses. There are some limitations of the high-low method. Uses only 2 data points. Ignores all other observations. Extreme points may be outliers that distort the estimate, no measure of how well the line fits the data. Dive into regression analysis, where least squares regression offers a mathematically robust approach. This slide explains the equation y equals a plus bx and unpacks key concepts including residual term and R-squared. It also touches on multiple regression when more than one cost driver is involved. The method is superior due to its comprehensive use of all data points and objective evaluation, ensuring a more accurate prediction of cost behavior for better outcomes. Explore regression in Excel using Gator Beach Marts data as a practical case study. 2 methods are demonstrated: the Data Analysis Toolpack and Excel functions like slope, intercept, and RSQ. Notice how regression results reveal intercept, slope, and R-squared values that form a cost function for predicting expenses. A comparison with the high-low method shows differences in accuracy, guiding you to choose the best approach for cost estimation, enhancing your overall analytical skills. Uncover the secrets behind Excel's regression output as you learn to interpret key metrics. This slide details the regression statistics table and coefficients table, highlighting R-squared, t-statistics, and p-values. Understand standard error and confidence intervals with clear rules of thumb for significance. Use 3 criteria to evaluate whether a cost driver is appropriate. 1. Economic plausibility: does it make sense that this activity causes the cost? There should be a logical cause and effect relationship. For example, machine hours logically drive electricity costs. 2. Goodness of fit: R² measures how much of the cost variation is explained by the cost driver. R², 0.90 equals excellent fit. R², 0.70 equals good fit for cost estimation. R², 0.50 equals poor fit. Consider other drivers. 3. Significance of independent variable: statistical tests determine if the relationship is real or due to chance. T-statistic, absolute value. T-statistic, 2 suggests significance. P-value, 0.05 means statistically significant confidence interval. If the 95% interval excludes 0, the driver is significant silent. In this example titled Reading Regression Output, we examine data from Gator Benchmarks. The regression statistics show a multiple R of 0.9838 and an R² of 0.9679, confirming a strong model fit. The coefficients, with an intercept of 407.14 and a significant hourly rate of 2.14, indicate that hours play a crucial role in cost behavior. This analysis validates the positive cost driver using both economic plausibility and statistical significance. Indeed, in this slide titled Evaluating Cost Drivers, we assess 3 essential criteria for choosing an effective cost driver: economic plausibility, goodness of fit, and significance of the variable. The colored icons and clear layout emphasize that a logical cause-effect relationship, a high R² and a steep slope ensure reliability. Reflect on how these factors interrelate and guide cost management decisions in real business scenarios. Consider which criterion seems most critical. Think deeply. In the slide Nonlinear Cost Behaviors, we explore varied cost functions that deviate from linear models. Through 4 distinct boxes, the slide illustrates economies of scale, learning curves, step cost functions, and experience curves. Economies of scale. Average cost per unit decreases as volume increases due to spreading fixed costs and volume discounts on materials. Step costs. Costs that remain fixed within a range, but jump to a new level when capacity is exceeded. Example: adding a supervisor for every 20 workers. Learning curves. As workers gain experience, the time required to produce each unit decreases. This is especially important in labor-intensive industries. In the Data Collection Issues slide, we examine common challenges and practical solutions for acquiring accurate cost data. 6 issues, from time period mismatches to inflation effects, are highlighted with clear warnings and targeted recommendations. Each block directs us to more reliable data collection methods essential for valid cost estimations. Reflect on these pitfalls and consider how systematic data practices can improve the credibility of your managerial accounting analysis. Overall, strengthening managerial insight. In the Key Takeaways slide, we consolidate essential cost behavior concepts into clear, memorable points. Cost functions. The linear cost function y equals a plus bx is fundamental to cost analysis. Variable costs change with activity. Fixed costs remain constant within the relevant range. 2. Classification criteria. Consider the cost object, time horizon, and relevant range when classifying costs as fixed or variable. 3. High-low method. Simple but uses only 2 points. Calculate slope first, then intercept. Good for quick estimates. 4. Regression analysis. More accurate because it uses all data points. Excel makes it easy with slope, intercept, and RSQ functions. 5. Evaluating cost drivers. Check economic plausibility, R superscript 2, goodness of fit, and statistical significance, p-value less than 0.05. 6. Nonlinear costs. Recognize step costs, economies of scale, and learning curves. These require special treatment in analysis. 7. Data quality. Always plot data first, investigate outliers, and ensure costs and activities are properly matched in time.